So when we sat down trying to figure out how we're going to achieve these performance-based objectives, we created a matrix and said, okay, what concepts do we know about? What concepts have been successful in other areas? Really tried to do a comprehensive review of what was out there. And as I mentioned, cost is one of the considerations. Late 2005, I sat through the Let It Rain conference, and we were talking at that point about Burke Mountain having infiltration trenches on the lot at $7,500 a lot. And you're talking 400 or 500 lots in this neighborhood alone. We wanted to make sure the measures we chose were the best value, not necessarily the most expensive, and not necessarily the ones that were done most recently. So we considered all of the options and came out with, again, through all the guidebooks, you've got your subdivision level controls, like the ponds, your conveyance controls, potentially in the municipal roadway, your site controls, which we had on the townhouse strata level sites, and your individual lot controls, which will be talked about in a few minutes. David showed at for East Clayton, very similar concept here. East Clayton started out with open swales with deep topsoil, and they moved to a pipe system. What we used was very similar to that in terms of the infiltration trench is behind the curb, it is in the boulevard, it is in the municipal right-of-way, so it's owned and maintained by the city. The difference here, though, was that instead of trying to get the water into the boulevard to start with, we started with the water in the catch basin. And we looked at it and said, well, from a normal functionality point of view, that's typical. You've got your curb and gutter, you've got your catch basin, you've got your storm sewer under the road. That is typical. So from that point, everybody knew how to build this, which was most helpful. The difference, though, is that instead of the catch basin going to the storm sewer, the catch basin kicked the water back into the infiltration trench behind the curb. And there's a couple of advantages to this type of system. First, it's basically a redundant system. It allowed us to plug it and keep it offline until such times as the erosion sediment control and the lot grading was done. There were a couple of comments about how do you keep these things from silting up, how do you keep the infiltration trenches working. And let's be honest, if you have that trench trying to filter water for the first 2 years of construction, it's not going to be much good to you on the 3rd year. It will be plugged up. So allowing it to be a redundant system allowed us to plug it, keep it offline until we knew that the water quality was where we needed it to be. We were dealing with steep hillsides, and so if you have one big, long, linear trench behind the curbs, the water simply goes down to the bottom. One of the design components here was to make short, isolated trenches. So you end up with the water infiltrating, stopped, held back, moved on to the next trench, and just having a series of these instead of one big one. I mentioned that the design details are not legible at this scale, but the point really is that, as I mentioned, you've got the water in the catch basins going to the trenches first. You've got the water that then fills up along the trench and everything in behind the curb then goes to the storm sewer. You've got a mostly typical city road cross-section. For anybody that has tried to conjure up a brilliant new idea for the road city cross-sections, you'll know that these sections are this way for a reason. And once you start moving one and you start impacting the utility corridors or the street lighting corridors or where the trees are, you don't really have the flexibility you think you do on a typical road cross-section. So this follows mostly a typical section. You've got extra depth topsoil in the boulevard. You've got an infiltration trench on the low side. These are only on local roads, not the arterials and the collectors, so it's just smaller areas. Sorry. Let's go back a few steps here. The open bottom concept, I talked about the high groundwater, and the point is that we had to do all of this within the first few feet on the surface. Anything deeper, we were going to be into the groundwater, we'd have the reverse effect, we could pull in water back. So the trench is right underneath the curb, the detail of the catch basin, detail of the lawn basin. These are all the similar type things that you'll see in the boards outside, but it's a matter of formalizing and allowing somebody else to improve upon it. So these are conveyance level controls that we had. Then we start talking site controls. Somebody asked about disconnected roof leaders. Disconnected roof leaders on single family houses. We came out and said, disconnect the roof leaders on multifamily houses. This was a difficult challenge to get everybody to buy into, because we know that the homeowners in Clayton, first thing they did when they had soggy yard was pipe that into the pipe system. So not only did we have to disconnect the roof leaders, but we had to have infiltration trench going through each of these projects. There are 8 or 10 townhouse sites in these NCPs. Again, not legible, but the point is that the clients paid to install a second perforated infiltration trench throughout almost all of the landscape areas on all of their projects. And several of those clients are in the room today. It is expensive, but when we evaluated them, we figured they were the most effective, most efficient way to achieve our performance-based objectives. So these are just different site plans. The question of implementation comes up, and the point is that we did the NCP and came up with the concept, but these site plans show that, in fact, each of the developers in the area followed it, each of the developers in the area did it, and that'll be part of Ken's conversation coming up next. The final point comes to, we talked site level, we talked conveyance on the streets, we talked site level for the townhouses. The single family measures that we prescribed, and they were prescribed, everybody that worked through them had to follow those, was the extra depth topsoil. There were perforated lawn drains with perforated leaves and things. The same concepts followed through to each level of development, so that there was some redundancy. If one didn't work as well as we wanted to, the next one would, and then the next one would. And at the end of the day, this area is still under construction. We don't have monitoring or results as of yet. But in terms of building on the lessons learned in Clayton and trying to find the best measures to implement, we think that the NCPs in North Grandview and Grandview Heights #1 were the next generation, and something to build from. So, any questions on where we came from or why we did what we did in North Grandview?
Just one quick question. What were the soils like? Were they clay as well, or was there actually some sandy topsoil?
Not so much the sandy topsoil. I mean, there was a fair bit of topsoil we could reuse, so that was certainly helpful. There's a lot of clay in the upper regions. It was, the connectivity isn't very good, but there are gravel seams, and so when we did the hydrogeological study, there were seams of gravel where the water was popping out of the hillside. Varied. We kind of have a bit of everything.
So did you target your infiltration to the areas where the gravel seams were, or did you try and push it into clay?
We set the system up so that it would pass. We didn't want to go much deeper than, say, 2 or 3 meters. No deep well injection. We didn't want to be pulling water back from the ground. But in those areas, yeah, our trenches oftentimes were 1 or 2 meters deep to try and take advantage of various seams that we could find.
What kind of costs per lot was there in Springfield? And then did you add it?
Do you have a better understanding? I mean, I believe we were into the $1,500 a lot, keeping in mind that a significant portion of the costs were on the municipal right-of-way. So, but taking it from the original example of, say, $7,500 a lot, we had a lot of multifamily here. We figured we're down closer to $1,500 or $2,000 a lot. There's still a premium for that.
What kind of hydrographic do you have for the natural flow areas in these areas, so you can demonstrate to me that when you're done, you've actually succeeded in regulating the flow of these watersheds?
It's a good question, and the answer lies in we have the modeling data. The model was not calibrated. I can't prove to you that the 80 liters per second my model says is actually what's running through that creek, but we do now have several years of significant rainstorms, several years of analysis downstream to show us that, yes, in fact, where we said we needed to upgrade Old Logging Ditch so it wouldn't overflow, it's not overflowing now. Where we said that this culvert would be full, it is almost full. I mean, we have some of that kind of analysis, but not the detailed numbers.